Alright, number 7 on the blue packet. So we have a bouquet. It's tossed in the air, traveling for 2.2 seconds before landing in the hands of a hopeful future bride. So we have our bride tossing flowers that are pretty much as tall as her entire body to somebody that's a certain distance away. So with our given information, we are provided that the initial velocity of the bouquet leaving the hands is 13.2, and it leaves at an angle of 53 degrees. So step 1, again, every time you're given initial and an angle, is to find the components. So searching for VOX and then VOY. So plugging all of that in, we will get an X component of 7.94 and then a Y component. We'll actually do that math, is going to be 10.54. So we have a VOX of 7.94 meters per second and then a VOY of 10.54. So plugging that into our table with the other information that we know, which is time x is 2.2, we're trying to figure out the difference in height between where it left the bride and where it's going to reach the person catching it. So delta x is going to be VXTX. So even though this is part B, it's going to be easiest to find. So the distance is going to be our x velocity multiplied by our total time, 7.94, multiplied by 2.2. And that's going to tell us that the overall distance that the catcher is from the bride is 17.38 meters. So that's how far away the person is standing from the bride. Again, answer to part B. So now we're trying to figure out the difference in height between where it left the thrower and where it reached the catcher. So this is a slightly more complicated piece of data. So we can find the time up. So V final Y is going to be the V initial Y plus gravity times time. Final Y at the peak of the toss will be 0. Initial Y is what we calculated to be 10.54, and that's minus 9.81 multiplied by the time, and that's going to get us our time up. So doing that division of 10.54 divided by 9.81 will get us a time up of 1.07 seconds. So that means our projectile goes up for 1.07, peaks, and then falls down a certain amount. So I'm just going to figure out what that height is. So delta y cliff to peak, which is going to be release point to highest point, is going to be 1/2 times gravity, which is negative 9.81, multiplied by the time that we just found. Again, we can use the idea that there is a symmetrical relationship between the left and right side of a level projectile to find this time and find this height instead of doing the more complicated equation. So we are going to calculate, ultimately the bouquet is going to get to a point that's 5.66 meters above where it was released. Then we are going to use the fact that the total time in the air is the sum of the ups and downs. So 2.2 is 1.07 plus time down. So solving for that, we get that time down is the subtraction of 2.2 and 1.07, ultimately telling us that our bouquet is going to fall from its highest point for 1.13 seconds. Then from here we can calculate the distance of the fall, which should be 1/2 gt squared. So the delta y of the fall, we will use the time that we just calculated. So 1/2 times negative 9.81 multiplied by 1.13 squared, and that's going to get us the distance that we fall down from our highest point. So doing that math, we're going to end up taking the whole equation, putting it together, and we're going to get that it'll fall 6.26 meters from its highest point. So just looking at this from a visual perspective, we are going from the hands up to the peak, which exists at 5.66 meters. And then we are going from that highest point down to the person catching it, which is a larger value. So that implies that the object is being tossed or released from a point higher than it is being caught, based on the fact that it's falling down. So 5.66 up, 6.26 down. We are trying to find the change in delta y distance. So all we have to do is take the subtraction and calculate the difference between those two distances. So taking our 5.66 and subtracting our 6.26 from that value, we are going to get that the difference in our hand levels is going to be a value of 0.603 meters. Negative because it's falling down instead of rising up. So that means that the hands of the person catching it are lower, obviously, than the person throwing it. Now there is another alternative to solve this way. Like the ones we've done in class, you could just find the delta y after 2.2 seconds and avoid the up and down section. Totally up to you how you want to do it. It's just a matter of what you feel more comfortable working with. If you decide to do the overall time, you would use the delta y is equal to v initial times time plus 1/2 gravity times squared relationship, and plug in the v initial y that we calculated at the beginning and the total time of 2.2, and that should yield the same answer.